All right, I'm going to go ahead and take a moment to answer some more questions that have come up about this next part. First, I'll take a bit to give a recap on some of the earlier information, and then we'll move on to what's new for Part D. So please remember that for each partner in the group, you need to have a new slide for each different part that you're covering. So that's going to be really important for 4 and 5 for these objectives that we have for Part D. Remember that for each different partner, for each different slide, everything needs to be clearly labeled. I need to know exactly what it is that you intend to cover with the slide. Sometimes students try to combine these or try to put more than one person on a slide, and I can't figure out where to put points. And so people end up just not getting the points. So please make it easy for me to find. I have many hundreds of these to go through. My eyes aren't that great anymore. Just try to help me so that I can help you to get more points. All right, remember, again, very clearly, label with the name for whoever's covering the slide. Make sure to tell me what the slide's supposed to be part of and what's supposed to be covered on the slide itself. Okay, and then remember, each different partner has a different slide for each of these minor objectives, right? So this time for Part D, we're looking at 4.1, 4.2, 4.3, 4.4, then we keep going, 5.1, 5.2, 5.3, 5.4. So those are the minor objectives as listed on the addendum in Module 0. Okay, so each time, one partner per slide, one slide per partner. Everybody needs to do each part. Notice that this name has a 1.4, an irrelevant scientist. Here's a different name, which is clearly not an imaginary person or the same person with a different picture. Different name. Same objective. New information. All right, these need to be different from each other. It's very important, especially for the part that we're about to work on. Okay, so for Part D, again, that's major objective 4 and 5. So that's going to be all of these that start with 4 or 5. Those are the major objectives, and then the minor objectives are going to be the point whatever that follows. The basic idea of this whole part is that you're going to develop a question, something similar to like what was shown in the lecture videos. A little short question, a couple of steps to solve, some actual numbers involved related to the topic that you've got here. This should be something that you can make a graph out of. So it should be something where you can plug in multiple values, find different answers, find a relationship. It needs to actually relate to the topic. So don't deviate from the name of what your group is. Then it needs to be, for each of your questions, needs to be significantly different from what your partners have. So vary it up as much as you can. For some topics that may be difficult, but use different types of objects, solve for a different force, use a different radius, whatever makes the most sense for your topic. Try to vary it up as much as you can for each different person. Okay, so now going through these different minor objectives for 4.1, this first one, you want to kind of set the story of the question that you intend to work on. So we're going to give the pretext. We're not going to do much solving or additional information here, but you're setting this up. So, give what the question's going to be. Don't do any solving your answers yet. Explain how it relates to your topic. If you can, relate back to earlier parts of the project. If it's related to anybody's scientist that they talked about in an earlier group, if it's related to anybody's related field from an earlier part, anything like that, bring that in. Justify your question, explain how it's good, make somebody start to get interested in what's happening here. Make sure that this is an actual problem solving. It needs to have numbers, things to solve, steps to do, right? So don't make it a fill in the blank question. Don't make it a conceptual question. There needs to be a little bit of solving in here. It doesn't need to be super complex, but something that uses either your law or your formula or solves for your constant or uses your constant to solve for something else. Again, that's going to vary by topic. Over and over and over again. One student per slide, one slide per student. All right, now 4.2. This is where you're going to really sell the question, make somebody understand the benefits of going through the trouble of figuring out how your question works, right? So what skills can they gain? What can a person figure out? Are they going to learn how to solve something that's a quadratic? Are they going to learn about new forces? Are they learn about relationships between different parts of the ideal gas law? What kinds of things can this be extended to? If you're dealing with one of the laws of thermodynamics, maybe another one of the laws of thermodynamics can be solved after this type of question. If you've got one of Newton's laws, maybe your setup can tie in some of the other of Newton's laws and, bring these together and help a student learn even more new physics, right? So keep those kinds of things in mind. I keep saying it, and I'm going to keep saying it again and again, but one student per slide, one slide per student. Each different person in your group is going to have a different question where they're going to tie together 4 and 5. So make sure that these are unique, make sure everybody has slides, make sure that they're properly labeled. All right, 4.3. With this one, you want to start to describe how you made your question and why it is a reasonable question. Okay, so you might have come up with an idea because I don't know, you saw an animal, or you watched a kid on the swing, or you thought about the moon going around the earth. How did you come up with this question? What was the development process like? Then also, show that your question is reasonable. It can't be too simple, right? So don't just have your question be, name which of Newton's laws explains this scenario. We want to have some solving involved, right? We need some steps and a little bit of algebra and, talking about units and formulas, but also make sure it's not too difficult. If you need differential equations or logarithms or exponentials or anything like that, keep in mind that this is something that you're going to try to explain to somebody later. You're going to have to try to at least kind of, sort of, a little bit teach this concept to somebody. And then explain why it was kind of difficult to narrow in and pick your question and develop what it was going to be. Right. So again, think about what your teachers might go through trying to write questions and trying to make sure that they're not too tough or too easy or too strange to understand. Once more, one student per slide, one slide per student. And then last part for major objective 4, remember that for part D, though, this carries on. So right now we're still sort of generating the question, talking about how it was made, why it's important, what you can do with it. Here, again, the last little selling point for your question for 4.4, why is your question special? What makes your problem new and unique? What did you add compared to what it might have been a different question? So if you wrote a question about Charlie the chicken, tell me why you came up with that, right? Why is your Charlie the chicken question, your story about what's going on in that question better than somebody else's, right? So, compare your question to things that you might find on the textbook and internet. Try to explain why your question's better, right? Why is it different? What's special? Why is it above and beyond what somebody might find if they just Googled your topic or if they just flipped through the textbook? Once more, one student per slide, one slide per student. All right, so we've set it all up. We've sold it. We've got people interested. Again, everybody wants to know how your question works. Now we're going to actually start setting it up, solving, getting to the real meat of the information. You need to be able to generate a graph or a plot or a table, list some information together, draw a picture. You can use Excel for this. There's probably a billion different websites out there that'll help you make a graph or to track information or to make a scatter plot, or there's a lot of different things that you might decide to do. But we need a range of values. You want to try to explain the relationship. Use words like linear or quadratic or inverse or exponential or nonlinear, right? So if you've got a picture that goes off like this, explain what that shape means. If you've got a graph that comes down like this, explain what that might mean. If you've got a graph that just goes straight like that, explain what that means. Relate the shape or the slope to something. Maybe this is related to gravity or a spring constant. Maybe this is related to separation distance between something. Explain those things, right? So again, we're doing the setup. We're trying to introduce the information. We're trying to eventually teach everybody how to solve your question. So we're just beginning in objective 5 here. Again, 1 student per slide, 1 slide per student. So make sure everybody has their own different question. Make sure everybody has their own different 5.1 slide, and then we'll continue on to the next one. Okay, 5.2. With this one, we're going to start sorting through all of the relevant pieces of the information here. So look at the formulas that are involved, the units that are involved, any definitions that are here. So if you've got some formula, a simple one that might come up quite a bit, be F equals MA, or W equals MG, or F equals KX. There could be a lot of different things. Show the formula, go through the different letters, say what they all are. Show how you might solve that formula for different variables. Explain what those variables mean and what kinds of units they might have, right? So go through, talk about the variables, talk about the pieces of the formula. These things are related to each other. In a lot of these questions, there's going to be some kind of constant involved. So that could be a universal constant, something that is always true no matter what, or that could be a local constant, maybe something that's only true on Earth, or between 2 different types of masses or 2 different types of charges. Talk about those things. If in a type of question you would hold something constant for just a little while, or like I said, if it's local to a planet, or if it works everywhere in the universe, talk about those things. Explain the units on the constant. Explain the units on everything. If it's kilograms or meters or seconds or newtons or joules or watts or any of these things, bring them up, right? Show your formula, do unit analysis, show the formula, and then replace the variables with the units that they have and show how it works out and how it makes sense. Once more, 1 student per slide, 1 slide per student. Make sure everybody's got their own unique stuff. As much as you can, try to be different from each other. Still relate to the topic, but try to vary it up. All right, getting towards the end of part D here, 5.3. Here's where we do the actual solving, right? So this is what I was saying from earlier, but there's got to actually be some solving or you really can't do this part anyway. So that's one way that you might lose points on this slide. If you didn't solve anything, if you put A, B, C, D, and somebody's just supposed to pick the name of the law or the scientist, that's not a good question. Show the full solution process for solving your question. Should be multiple steps, right? Show some work, show some detail. Don't just say, oh, algebra happens when we get to this. If you've got to divide to rearrange, if you take a square root on something, again, become the expert on your particular question. And then solve, show how it works. Give steps and details. Depending on your setup and equipment and how you're working on things, I understand if you can't draw at the same time as this. But if you have to, pre-type this ahead of time, then type in a lot of detail and then at least point to stuff and say why it was important, right? So make sure that you're showing something here. Again, you're trying to teach this to anybody else who might see the video. That's probably only me, but pretend like you're teaching a full lesson here. Okay, so give a lot here. Make sure it's not basic. Make sure it's involved and that there's extra stuff going on. Right? So make sure 1 student per slide, 1 slide per student. Make sure everybody's got something brand new, unique, and different for each person. Please don't give me 4 or 5 of the same exact thing. Okay, last one for this part. Then we want to validate everything that's going on. Verify that the solution is actually correct. This could be something that could go back to the graph that you had in the earlier step, right? So maybe you plotted data points for every half a kilogram on something. And maybe your example question had like 2.76 kilograms. And then you can show, hey, look, this answer would fit right here on this graph, and this makes perfect sense. Show how the units work out. Again, think about the range of values. Show how it could fit potentially on the graph you had earlier. Excuse me, so it might be useful to show your graph again, or maybe back up a couple of slides. Please don't use exactly the same graph as your picture here. Find some new picture to go along with it, or at least draw on your graph and update it to make it some new picture on this part. Verify again, go all over, finish your selling point. Explain why the solution process was valuable. Why was it a good idea that somebody might watch and pay attention to and learn from what you showed in this group of slides? Okay, last time for today. Make sure you've got one student per slide, one slide per student. Everybody needs to do a brand new, unique, and as different as possible scenario for part D. If you have any questions, please let me know. Otherwise, thank you and good luck.